Lesson 10.8, Trigonometric Ratios. Our essential question is how do you determine which ratio to use when solving for the missing side of a right triangle? So we are going to be learning three new trig ratios today. These trig ratios are all used with right triangles, and they can be used to find the length of any missing side. What's different about the trig ratios versus the Pythagorean theorem is, with the Pythagorean theorem, you typically had to know two of the side lengths in order to find the third side of the triangle. Now we might know one angle measure and one side length, and we can use that information to find any of the missing angles or sides in the right triangle. So SOHCAHTOA is what we're going to use to help us kind of remember the trig ratios. The S, C, and T in SOHCAHTOA stand for the sine, cosine, and tangent. Those are our three different trig ratios. The sine of an angle is the ratio of the opposite side to the hypotenuse. Opposite to the hypotenuse. So if we're looking at a right triangle, like this, I'll call this triangle ABC. If we were talking about the sine of angle A, so right here, so sine A would be equal to the side opposite over the hypotenuse. So it would be a ratio or a fraction comparing those two side lengths. The next trig ratio is called the cosine. The cosine is the adjacent side over the hypotenuse. Adjacent means next to.
Please turn your TVs to channel 67.
So the side that would be adjacent to A would be right here, next to. Now you may be looking at this picture saying, well, the B, this little B over here, looks like it's also next to that capital A. That B represents the hypotenuse. So the opposite and adjacent are legs. So opposite leg over the hypotenuse or adjacent leg over the hypotenuse. So if it was the cosine of angle A, that ratio would be the adjacent leg, C, over the hypotenuse, B. My last one is called the tangent, and the tangent of an angle is the opposite leg over the adjacent leg. So again, if we were just talking about in my other picture, the tangent for angle A, opposite was the little a, and adjacent was the little c. Okay? Now back to this word SOHCAHTOA. Sine is opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So you can see in red where those letters are coming from for that acronym SOHCAHTOA. So the idea is that if you are expected to memorize these sine, cosine, and tangent ratios, the word SOHCAHTOA helps you to remember which sides you're using. So you really need to know how to spell that word, SOHCAHTOA. Okay, so find the values of the three trig ratios for angle A. So sine A, cosine A, and tangent A. SOHCAHTOA, spelled like that. Okay, so the sine is the opposite over hypotenuse. So starting with angle A, I need opposite over hypotenuse. So, it says hint, find A first. Well, if we know two of the sides, I guess I'm going to have to use the Pythagorean theorem to find the third one. So A squared plus 9 squared equals 15 squared. So 81 subtracted from 225 and then I would take the square root, so A equals 12. So I know that A is 12 now. Now I can write my ratio. So the sine would be opposite over hypotenuse, 12/15, and that would reduce to 4/5. My cosine of angle A, adjacent over hypotenuse, adjacent over hypotenuse. Adjacent to the A is the 9. Remember, 15 is the hypotenuse, so we can't use that for both. So divide these by 3, and I get 3/5. And then last, the tangent is opposite over adjacent. So opposite was 12, adjacent was 9. Divide them by 3, and I get 4/3. So there are my 3 trig ratios. The next problem, this is just a calculator problem. Sine of a 31-degree angle, if you put that in your calculator, it will tell you 0.5150. Typically, with these ratios, when you're using a calculator, you want 4 digits after your decimal point. Tangent 76 degrees tells me 4.0108. And cosine 55, .5736. So again, those are just calculator problems. Now, this problem says solve the right triangle, and it says find all of the missing angles and sides. Remember that all of the angles have to add up to 180 degrees. So, if I've got 90 and 51, and then B has to add up to 180 degrees. So, 180 minus those 2 angles that I know would leave me with 39 degrees for angle B. So, this angle is 39 degrees. Now, I only know one side length. I only know one side length. So what I'm going to do is I'm going to use a trig ratio here. So take a look at my 51-degree angle. I know that the sine of that angle A equals opposite over hypotenuse. So I can go with 11 over the hypotenuse, which is AB. And I can solve this proportion. I'm going to put a 1 under my sine, and then I am going to use my calculator like we just did and solve this. So the sine 51 is 0.7771. So now take a look at this proportion, and I can cross multiply and divide to figure out my hypotenuse. So 11 times 1 is 11. So 11 divided by 0.7771 gives me a hypotenuse of about 14.2. So this side is 14.2. Now that I know 2 sides, I can do the Pythagorean theorem. So 11 squared plus b squared equals 14.2 squared. 121 and 201.64. Subtract the 121. I get 80.64. And then I just need to take the square root. And it's about 8.97, so it's about 9. So now I've got all of the missing side lengths and all of the missing angles. Next problem, same thing. So start out with your angles. I've got 90 and 35, and I don't know B, but I know they have to add up to 180 degrees. So 180, if I take away 90 and 35, angle B is 55 degrees. Now, you can use any trig ratio to figure out these side lengths. I could use sine, cosine, tangent, but looking at this triangle, I noticed that 7 is my hypotenuse. So with SOHCAHTOA, I'm going to have to use one of the ratios that has that hypotenuse in it. So I could use the sine or the cosine. So this time I will show you using the cosine. So let's do the cosine of angle A. So cosine of angle A is going to be the adjacent side. So the adjacent side is right here. So I'm going to say the cosine would be adjacent over hypotenuse. And instead of cosine of angle A, remember we know that A is 35 degrees. So the cosine 35 degrees, and then I make it a fraction. So now I've got 0.8192, and I can cross multiply and divide to figure out the length of x. So 0.8192 times 7, and if I divide it by 1, I get 5.7. So this side over here is about 5.7. Now I can do the Pythagorean theorem. 5.7 squared plus b squared equals 7 squared. Remember, 7 is my hypotenuse. So 32.49 plus b squared equals 49. So subtract that 32.49. B squared, 16.51, and then take the square root. And B is about 4.1. So this side is about 4.1. So now we've found all of the side lengths and angles that we're missing. Okay, our last problem says the angle that a skateboarding ramp makes with the ground is 25 degrees. 25 degrees. So let's see. Maybe I'll just draw this one. So I've got a skateboarding ramp like this, and it's making a 25 degree angle with the ground. So that means that my angle right here is 25 degrees. The height of the ramp is 6 feet. Here would be the height of your ramp, and they're looking for the length of the ramp. So this would be the length of the ramp. So here's my skateboard ramp right here. Okay, so now, what ratio would this be? What ratio would this be? Think about SOHCAHTOA. Which ratio would we need to use here? The relationship between the angle that's 25 degrees and the side that is 6, that would be your opposite side. And then the x is your hypotenuse. So the ratio that I need to use is the one that has the opposite and the hypotenuse in it, so it's a sine ratio. So the sine of my 25-degree angle equals the opposite side over the hypotenuse. Put a 1 under it, use the calculator. So 0.4226 over 1 equals 6 over x. And then we need to cross multiply and divide. So 6 times 1 is 6, divided by 0.4226. So the ramp is about 14.2 feet long. So in solving these problems, the key is probably to draw a picture. If it's a word problem like this, you need to draw a picture. You need to label the parts, and you really need to look at which ratio you could use. So look at the relationship that the sides have to the angle that is given to determine which ratio to use. So in my picture, the 25-degree angle is related to the side 6 because that's the opposite side. It's the opposite leg from that angle. And then the hypotenuse is what we were looking for. So the only ratio that would make sense to use is the sine ratio. On the previous problems, you were looking for all of the information, so you had a little bit more flexibility. On this problem, because you were given the hypotenuse, you could have used either the sine or the cosine to start out, because the hypotenuse and the 35-degree angle were the two that were given. If you had used the 55-degree angle, you still only know the hypotenuse, so it would still be a sine or cosine. And then in this first example, because you were given the 51-degree angle and you were given the side 11 that was opposite, you could have, from your trig ratios from SOHCAHTOA, you could have used either of the ratios that had the opposite side in them. So you could have done a sine or a tangent first. A sine or a tangent first, using that 11 in relationship to the 51-degree angle. You should be able to write a summary now. And here are your homework problems.